Hey guys, so let's have a look at this question. In this question, you have a parallel plate capacitor which is filled by a dielectric, and its permittivity varies with the applied voltage according to the law epsilon is equal to alpha u, right? So there's a slight mistake in this question. This is not supposed to be permittivity, this is supposed to be relative permittivity, right? So let me fill that in. This is actually epsilon r or your K. So your K value, so you have a parallel plate capacitor which is filled by a dielectric, and the dielectric constant of this capacitor varies with the voltage, right? And it varies according to the voltage according to this mathematical expression where alpha is a constant, right? The same capacitor but containing no dielectric is charged to a voltage u naught, and then it is connected in parallel to this non-linear uncharged capacitor, right? Its permittivity is not constant is what the statement means. So with that, we are supposed to find out what will be the final voltage across the capacitors, right? So let me describe the scenario in terms of a circuit diagram. So what we have over here is we first have let me draw this capacitor. So this is a capacitor without the dielectric. So let me assume that its value of capacitance is C, right? And that is being charged to a voltage of U naught. So that means the charge you will have on this is plus CU naught and minus CU naught on both its plates. And now it is connected in parallel to a similar capacitor but with the dielectric in between them. And your dielectric is not having a constant dielectric constant. It varies with the applied voltage. It varies with the applied voltage over here, right? So we're connecting this capacitor to another capacitor over here, and this capacitor with the dielectric, right? We are supposed to find out what will be a final voltage across capacitors. Okay, so let's go about it question. Let's go about this question right now. So let me assume that some charge transfer has happened. So this gave some charge to this. So let me assume that the final charge on this is x. So the final charge on this will be minus x. The final charge on this will be Cu minus x. The charge on this will be minus of Cu not minus x, right? Okay, and now we are assuming that these are the final charges. So if these are your final charges, then that means there is no more charge transfer happening between them, which implies that this plate and this plate must have the same potential. This plate and this plate will have the same potential, or your potential difference across both the capacitors has to be same, right? So let me write that final potential difference right now. Your final potential difference, according to the way I have expressed this question, will be equal to x by c. The final potential difference across both the capacitors has to be equal, and that is equal to x by c. But this x by c should also be equal to Cu naught minus x divided by the capacitance of this capacitor divided by the capacitance of this capacitor. Now how can I write the capacitance of this capacitor? We'll generally want to write it as Kc. But what's your K value? Your K value in this case for this capacitor depends on the voltage value, depends on the voltage across it. And the voltage across it right now is the voltage across this capacitor as well, right? Which is equal to x by c only. So your K value here will be equal to, your K or epsilon r both mean the same, will be equal to alpha into x by c, the final potential difference. So I can write the capacitance of this capacitor right now to be equal to so K into, so alpha into x by c into c will be your new capacitance of this capacitor. The permittivity right now depends on the voltage, and this is your final voltage. Your final voltage is x by c, so I've written that expression in this case, right? Now the aim is, x is an unknown. If I'm able to find out what x is, I'll substitute this in this equation and I'll find out the final voltage. So we'll solve for x from this equation. So c here gets cancelled. So our equation then becomes alpha x squared by c is equal to Cu naught minus x. So I'll get alpha x squared plus xc minus c squared u naught to be equal to 0, right? And this is a quadratic equation x right now. So what will the value of x be equal to? Your value of x will be equal to minus b plus or minus root b squared minus 4c by 2a. So it will be equal to minus c plus or minus root b squared, which is c squared, minus 4ac, so plus 4 alpha c squared u naught divided by 2a, which is 2 alpha, right? So this is the value of x, right? And from this you can see that the negative value is not possible because that would be a negative answer. So we'll only have the positive value over here. So what's your value of x? This is the value of x. So then what will be the value of x by c? Your value of x by c is dividing this entire equation by c. I'll get minus 1 plus root, so 1 plus 4 alpha u naught divided by 2 alpha. And this is nothing but the final potential difference you'll have across both the capacitors, right? So this will be your answer for this question. Your answer will be option number 4. So hopefully this question made sense. See you guys in the next question.